A heat exchanger is a device that uses conduction and convection to transfer heat. It helps make operation chemical plants to be more energy efficient. Fouling restricts the efficiency of this device. Among the causes are dirty fluids from sediments, corrosion of metal, and algae contamination. Control methods such as dispersants and chemical inhibitors are used to combat fouling. The removal of deposits can be done by hydroblasting. If that fails, chemical cleaning is used to dissolve them. If the deposits still resist, the heat exchangers must be purged using noble gases such as hydrogen.
Applications and classifications. Applications involve of three different categories. Is industrial, health services, third is domestic. In classifications of heat exchanger, it's involved of four many types of heat exchanger. It's tubular. Tubular can withstand high pressure and good sealing, which means that low leaking problem. Plate type. Extended surface. Extended surface involve of fin which increase surface area for heat transfer. Fourth is regenerative. Basic classifications flow arrangements. In heat exchanger is mostly involve two fluids. The two fluids can flow in three different kinds of combination, which is parallel flow, countercurrent flow, and cross flow.
I will be talking about the three types of heat exchanger. So the first type is the double pipe hairpin heat exchanger. So the first fluid to be cooled is flowed in from here and exits here, while the second cooling fluid flows in from here and exits here in a countercurrent manner. While the second one is the shell and tube heat exchanger. So it comprises of a bunch of tubes. It is the most common configuration in industries, and it has baffles so that the fluid flowing in from the shell inlet flows in a cross flow instead of just countercurrently. While the last one is the spiral wound heat exchanger. It is shaped like a screw, while it has integral fin tubes, and the size could vary from as small and slim as a pencil or industrially sized.
For heat transfer coefficient, external flow inline arrangement, maximum velocity can be found by using these equations. For the staggered tube arrangement, the maximum velocity can be found by using these two equations. After finding the Vmax, we have to find the Reynolds number and Cn value using this graph. After that, we have to find the Nusselt number by using these equations, and lastly, H can be found by using these equations. For internal flow, Reynolds number can be found by using this equation, and if the flow is laminar flow, we have to find the Grace number and the Nusselt value, and if the flow is turbulent flow, H can be found by using these equations.